Hello everyone. In this session, we'll start solving some problems on units and measurements. After solving these problems, you should be well versed with handling units and measurements. Let's go ahead. Okay, here there is a problem. A mass of liquid weighs 500 newtons when exposed to standard Earth's gravity, and Earth's gravity is given g equal to 9.806 meter per second squared. Hope you know the meaning of acceleration. Acceleration is equal to 9.81 meter per second squared. To understand it in better manner, you can put it this way: 9.81 meter per second it is. That is to say, the velocity of object when it freely falls, it will be gaining a velocity of 9.81 meter per second for every second. That is to say, you let fall an object. After 1 second, it will be reaching a velocity of 9.81 meter per second. If you continue to let it fall, at the end of second, it will be gaining 9.81 more. So to say, 9.81 plus 9.81. Like that, the velocity gets added up every second. That's why we call it as acceleration. So that is acceleration due to gravity is 9.806 or 81 meter per second square. Now what is asked is, what is its mass and what will be its weight in a planet with acceleration due to gravity 3.5 meter per second squared or 18 meter per second squared. Now here there are balances. When you put an object here, it will be counterweight by standard weights, right? Weight will be nothing but a force vertically downwards which will be acting on this pan. When you put an object, it puts a weight and it will be acting at this point of this particular balancing beam. So if there is a more force over here, it tries to tilt that way, and then you counteract by something else which can be measurable. It acts this way. When they become equal, when the forces become equal, we say that it is balanced. That's how this is called balance, right? It measures mass indirectly, because from this what we generally see is the force which will be acting, which is force is nothing but here weight, but it is calibrated such that we say that it is so many kgs, right? It is a mass. Even in this balance also, when an object is put on that, the force will be felt on this pan. Why put object? Even if you press it, right, when you apply a force, it shows some reading, right? Force means weight, so weight will be measured, right? Mass cannot be measured directly. That's why it's an indirect measurement. Whatever problem that is given here is an usual situation, means we'll be able to find the force or weight, and then afterwards we have to calculate the mass. Once mass is known, then if you know the acceleration due to gravity anywhere in other planets also, one can calculate weight on those planets. Okay, with this introduction we'll solve the problem. Okay, here I have shown some liquid or object, right? It will be possessing its own mass, but mass is acted upon by acceleration due to gravity. Because of that, it possesses what is known as weight vertically downwards always. You cannot keep it is inclined this way or that way, downwards but vertically downwards, and this W is equal to m into z, and it is given in the problem that it is 500 newtons, but the mass is, so to calculate that we use the standard equation Fw equal to m into z. This is parallel equation for F equal to m into a. Look at that. F, the force, is equal to mass into acceleration. If acceleration due to gravity is put, then we call that force as weight. So you can always now onwards remember that weight is a gravitational force. So after calculation you end up with m is equal to 50.99 kgs. So weight is 500 newtons, but the mass is 50.99 kgs. Okay, it is fairly simple. Okay, now further, what they asked is, if you are on a planet with acceleration due to gravity 3.5, what would be its weight? So the mass of the fluid remains constant. M is constant, as I told you, regardless of its location. Hence m equal to 50.99 kg. It remains as it is. Now on the first case, G will be equal to, G is given to be 3.5. How to calculate W? The standard equation, W1 is equal to m into G1. M is same, G1 is substituted, you get 178.46. On Earth, acceleration due to gravity is 9.806. Because of that, the force felt is 500 newtons, whereas here acceleration due to gravity is only 3.5. Because of that, the weight felt will be less. So it is 178.46 newtons, but the mass remains the same. It is 50.99 kgs itself. Okay, in the next situation, that is acceleration due to gravity, G2 is 18 meter per second square, almost double on the Earth. So now what happens? The weight W2 is equal to m into G2. Substitution will give you 917.8. So weight becomes 917.8 newtons, but the mass still remains the same. So from this problem, what did we learn? Mass of the object or a material or liquid, whatever it is, it remains the same irrespective of its location, means whether it is there on the Earth, on the moon, or anywhere else. As long as acceleration due to gravity is there, weight acts, but mass remains the same. Now weight changes according to the acceleration due to gravity, hence weight felt on moon will be less, though the mass remains the same. Okay, to the next problem. Second problem, a body has a weight of 400 newtons at standard Earth's gravity. When a force of 800 newtons is applied to the body, what is the value of acceleration on Earth and on moon, where the specific where gravity, that is acceleration due to gravity, is 1.6 meter per second squared. So on moon, you know that 1/6 of the Earth's gravitational force or acceleration acts, so they have given it as 1.6. The whole idea is, now if such a object is applied with a force, what is the acceleration? That is a question. Okay, now I think I would suggest to give a try with your present knowledge, whatever you have gained till now by studying science. It should be possible. So pause the video and solve the problem. I'm sorry, there is a spelling mistake here. yeah, solve the problem and then continue. The problem when you set for solving, because you can always take an object something like that as usual, the weight will be acting vertically downwards. Now the question is how this force is being applied. They have not specified, right? So for convenience I would suggest you take the force perfectly horizontal. So let the applied force of 400, no, weight is 400 newtons. The applied force is 800 newtons. So if you apply 800 over here, what happens to the object? What is the acceleration that it will be getting? Whether it gets an acceleration or not, first of all, and then what is the acceleration? So this is the free body diagram. When it is touching the surface of the, any surface on which it is being put, obviously there will be a reactive force also. So this is what is overall free body diagram. Okay, you try to solve the problem, we'll see. I'll go ahead for the next discussion. So they have said that it is having a weight of 400 newtons. I can always calculate mass. So weight equal to m into g, that's why m equal to weight by gravity on Earth's surface. That's why this is taken as 9.806. So mass comes out to be equal to 40.791. So this mass is calculated. Now mass is calculated how? Weight is given. We use W equal to mg. We have calculated mass. Now this mass is constant and does not change with the location. Whether it is moon or earth, it remains the same. Hence, when a force F is applied by Newton's second law, because it is said that it is applied with a force of 800 newtons. Now when you apply 800 newtons, obviously the object moves or tries to move, right? The mass is 40.791, applied force is 800 newtons. Nothing has mentioned about whether there will be a frictional force or something like that. So resultant force which is acting on this direction is 800 newtons. So you need not wait, you know this equation, F equal to m into a. Applied force is 800 newton, you know the mass, right? So I think acceleration can be calculated. It is fairly simple problem, so to say. So F equal to ma or a equal to f by m, and acceleration is 19.612 meter per second squared, right? So the force applied is 800 newtons. It is pushing the object with an acceleration of 19.612 meter per second squared. So now F equal to ma, this is the equation quite often used. So be well practiced to use it, right? You go for a number of variety of problems where mass, weight, etc. or force, that will be there, right? Okay, we'll stop here. Thank you.